Good morning, everyone. So, in this video, we're going to discuss all of the functional group test in organic chemistry. Now, before that, we have covered three steps for a test in organic chemistry or in organic chemistry practical. First one was preliminary or solubility method. Second one is Lasine test. In Lasine test, what you get to know whether it is nitrogen present in the molecule, in the organic molecule, or sulfur or halogen. If they are present in the molecule, you get to know that. Now is the third, is the most crucial one. This is the functional group test. Now if you get nitrogen in your molecule, then you will have to test for nitrogen associated group. That means nitro, cyano, isocyano, or amino, diazo, like this. If you get sulfur, then you have to check for thiol or SO3H, this kind of group where sulfur is involved, right? And halogen, chlorine, bromine, iodine, you can detect them from Lasine test itself. So we are here in this video to cover the third aspect, that means all functional group test. Now here, one by one, this slide I'm sharing you, this is very much important. All the information is written here in a very beautiful manner. So let's first discuss carboxylic acid group test. Now, when you will perform carboxylic acid group, if you have nitrogen in the molecule, then you have to perform nitrogen associated functional group test. But it is possible that in that molecule, one nitrogen associated group present as well as one carboxylic acid group present. So you will get nitrogen, you will not get confirmed whether oxygen is present by Lasine test, right? So you have to test the carboxylic group itself, and whether it is carboxylic acid group present or not, you get an indication from solubility test itself, right? Okay. So let's understand carboxylic acid group test. Now the test is also called sodium bicarbonate test. You have to do what you have to do: add sodium bicarbonate solution to the organic compound. Simple. You have a organic compound dust. So take some organic compound dust from spatula, and you have made one sodium bicarbonate solution. You have taken water and sodium bicarbonate dust, and you have made the solution. In the solution itself, you have to add that unknown organic compound. That's the simple thing. Liberation of CO2 gas with brisk effervescence. So a bubble of CO2 gas will you will have, okay, in that solution, in the sodium bicarbonate solution. If this is carboxylic acid group, you will get bubble of carbon dioxide. Okay, so the reaction occurring here will be, if carboxylic acid group present, then RCOOH, then sodium bicarbonate. The reaction will be, sodium bicarbonate is base. Sodium bicarbonate means Na, HCO3. HCO3 means C double bond O, O, OH, O minus. This is bicarbonate ion, right? Sodium bicarbonate. So this negative charge will attack hydrogen OH of carboxylic acid, C double bond O R. It will attack that hydrogen, and the sodium previously attached with that sodium bicarbonate now will be attached to the carboxylic acid or carboxylate ions. So RCOO and water and this CO2 effervescence. Now the question is, the CO2 effervescence comes here in the viva or interview. They can ask that in the CO2 effervescence, what is the source of that carbon of CO2? Now tell me, what is the source of carbon? It's obvious that RCOONA. This is basically RCOOH. Just this sodium atom now counter ion with RCOO. Then the CO2 cannot come from carboxylic acid. That's the carbon of sodium bicarbonate itself, isn't it? So this carbon is of sodium bicarbonate. Okay, so our carboxylic test is over. Simple sodium bicarbonate test. Now, a very good test of alcoholic group. So first we are discussing oxygen associated functional groups. So alcoholic group, OH attached to aliphatic part. Now there are two type of alcoholic test. If you suspect that your compound contains oxygen, that means you have received a test or indication in the preliminary method that there can be acidic hydrogen. Then you will have to perform the test for carboxylic acid or alcohol. That alcohol can be ROH. That means aliphatic alcohol, or it can be AROH, that means aromatic alcohol. Aromatic means this is also called phenolic alcohol. Phenol, don't confuse with the term phenol. We know this is basically phenol, and this OH associated with any aromatic ring also called phenolic OH. Suppose I have one compound that is nothing but beta naphthol. So this is our beta naphthol. Now here also OH is attached with aromatic moiety. We will also call this OH as phenolic OH. This is the term used in chemistry. Phenolic OH doesn't mean it should be phenol. It should be aromatic alcohol. So first we have to test for aliphatic part. If I expect if our compound is aliphatic, then OH test is different. Aromatic or phenolic, then test is different. For alcoholic, aliphatic aldehyde, that means ROH, aliphatic alcohol, ROH, and here is AROH. For AROH is CAN test, steric ammonium nitrate. So you have to add steric ammonium nitrate solution to the organic compound. Then formation of a complex gives red color solution. You will have a red color. If you get the red color, then it is confirmed that you know our compound contains aliphatic OH. Now I have a question over here, you as an interviewer or as a Viva teacher. My question is, in the molecule CAN, steric ammonium nitrate, this is the complex CeNO3 whole 6. Now, what is the oxidation state of cerium? It's my question. You comment it down, okay? Oxidation state of cerium. Then electronic configuration of cerium. Next, coordination number of cerium. Then geometry of the complex. The 4 questions you have to answer. You can Google it to clarify your answer. It's correct or not. But this is the 4 questions you have to answer by yourself in steric ammonium nitrate, and these are very important questions. These questions are definitely interviewer will ask if you perform the test, steric ammonium nitrate test. Okay, so final complex is red complex, red color complex. Now it is very important test for phenolic group. Phenolic group is simple FeCl3 test, and in the chapter phenol itself you also read this FeCl3 test. Gives characteristics such color of violet or green. Now you can have color of violet, you can get color of violet, green, or red. Even you can get red color here. And now how will you confirm that we have phenolic OH or not? Now if FeCl3 test, in FeCl3 test, if you get color change, then you can say that okay, my sample has aromatic OH. Okay, so color change should be there, colorless to color, and color can be violet, green, and red. Now what will happen? They have taken the example of phenol itself. So this is necessarily not be phenol. If it is like this also, then the test is kind of similar. Like this is alpha naphthol. This will the test will be similar for it also. Now FeCl3, what will happen? 6 such compound with aromatic OH will perform or will participate in the reaction with one FeCl3. Now FeCl3 means iron is +3 oxidation state, right? So here in this complex, iron is +3 oxidation state. Now this phenolic OH, what will happen? This OH will H plus will be dissociated. So this will be O minus, and the H plus will be taken by Cl. So 3Cl here will take 3 hydrogen, so 3HCl will form. And if you are taking 6 phenol, then you have more 3 more hydrogen, so 3H plus. Okay, so now we have phenoxide ion, 6 phenoxide ion. So iron will be coordinating with 6 phenoxide ion with the octahedral geometry. Okay, and the overall charge of the complex -3, because Fe +3 and 6 phenoxide ion, each phenoxide ion is -1. Okay, so overall this is octahedral complex. This is violet complex. Okay, and with if you vary the aromatic moiety, then with the variation color can be changed. That's why there are no fixed color. Okay, because it is a it is a kind of a variable kind of aromatic system. So you can't completely say this will be the common color. No, it doesn't work like that. More the aromatic moiety, more the pi conjugation, more the variation of color. Okay, so these were very simple, very basic, not so confusing. But confusion arises with the carbonyl system. There are so many tests for carbonyl. In the carbonyl chapter itself, you read about so much test. But in carbonyl chapter, what you read? Sodium bisulfite test, Tollens test, Benedict test, Fehling test, DNP test. But all the tests are not practically so much popular. In lab you cannot perform all these tests unless there is a minute variation. So mainly test is 2,4-DNP test is very popular, or DNP test, and this is also called Brady's test. 2,4-dinitrophenyl hydrazine, this is also called Brady's reagent. Okay, what will happen? Formation of so what you have to do is written here. So solution, you have to put the Brady's reagent solution in the organic compound. So in one test tube, suppose you have taken the Brady's reagent solution, and you have suppose solid your compound in a paper. Suppose you have the unknown compound, and from a spatula you take some portion and pour it here, and after that you have to shake. Okay, what will happen? Formation of orange, yellow, or red colored crystalline products. So final product will be crystalline. And if you have read hydrazine chemistry in carbonyl chemistry, then you know that the compound product name will be hydrazone. So from hydrazine, product name is basically hydrazone. How the reaction will occur? The carbonyl oxygen and this H2 of 2,4-DNP, 2,4-dinitrophenyl hydrogen. This is 2,4-dinitrophenyl hydrogen. If this two nitro not there, then this is basically hydrazine. Benzene, NH2. This is hydrazine. But if you are 2 and 4 position, 1, 2, 3, 4, there are nitro groups, so 2,4-dinitrophenyl hydrogen. Now this H2 and this oxygen, this will be removed as water. Water will be removed, and that will be that will be connected with a double bond. This is the new double bond that is forming. Now actually this reaction occurs. This reaction starts with the nitrogen lone pair attacks the carbonyl. This is how the reaction starts, and there is a long mechanism. But sometimes the question asked in an interview or viva that among these two nitrogen, what is going to react? Which nitrogen is going to react first? This lone pair or this lone pair? Which is going to attack? This is a basic GOC. This nitrogen lone pair is basically under conjugation, very high conjugation with this ring. But this nitrogen lone pair is not under conjugation. So this is very much available. So this will attack. This nucleophilicity of this NH2 nitrogen lone pair is very high. That's why it will attack. Simple. Okay. So our 2,4-dinitrophenyl hydrazine test is over. And which molecule will give the test? Aldehyde and ketone molecule will give the test. Now another test you can have performed, that Tollens test, iodoform test. Tollens test, Tollens reagent, aldehyde compounds give Tollens test, alpha hydroxy carbonyl compound gives Tollens test, hemiacetal compound gives Tollens test, and terminal alkyne gives Tollens test. And every time you will get silver mirror. Finally you will get silver mirror, and that's why it is called silver mirror test. So in this first first 4 cases, here you will get silver mirror. But in terminal alkyne they also Tollens positive, but here you will get white precipitate, white crystalline precipitate. Okay, so every Tollens reagent does not give silver mirror. Exception is terminal alkyne. Okay, and I am not discussing this too much details because this is the part of carbonyl compound chemistry. Okay, so why this is so you can learn there. So this is not the topic now. Now Fehling reagent, what does they do? Fehling reagent is the composition of Fehling A and Fehling B. This is called Rochelli salt, sodium potassium tartrate. So aliphatic aldehyde gives this test. Aliphatic aldehyde gives this test. Okay. So Tollens test, Fehling test is over, and Benedict test, something called Benedict test. You can write here itself when you will make the note. Write here Benedict test, BENEDICT, Benedict test. And in this Benedict test, the reagent is Cu2O. Maybe I may be wrong, but I can't recall right now. Benedict test is exactly similar kind of Fehling reagent. Okay, maybe Cu2O. The function of Fehling reagent is similar to Benedict reagent. Okay. So we are done with the Tollens Fehling Benedict segment. Now iodoform test. There is a popular reaction called iodoform test. And which compounds give iodoform test? The compound with CH3 C double bond O. Thus ketone compound. This is called ketomethyl group. C double bond O CH3. In any carbonyl compound where you will find this ketomethyl group, this will give iodoform test. Another group will be CH3 CHOH. These two type of system gives iodoform test, and final product will be iodoform CHI3. So this is iodoform test. How will perform? Very simple language. They have written that this is the way you have to perform the test. Just read this. Okay, this is very simple. As we are reading here practical chemistry, then not the behind chemistry, but the practical how you have to perform the test becomes important. But parallelly, you definitely have to know the what reaction is going on behind. Why I am getting the yellow PPT? Because it is the PPT of CHI3 iodoform. CHCl is chloroform. So chloroform doesn't give such taste. Why? Chloroform doesn't give. We don't say we are having a taste of chloroform test. No, not fluoroform test. We are not getting CHF3 test. So why this iodoform test only? If 3I2, if we replace it with 3Cl2, then we will get CHCl3. It is chloroform. Then why this is the problem? Why we don't say ki chloroform test or chloroform test or fluoroform test? The answer is, molecular weight, more the molecular weight, more the boiling point. In a previous video, I have discussed the factors determining boiling point. All the parameters we have discussed there. If you have not watched this, definitely watch that. Okay, so if molecular weight high, then van der Waals interaction high, then van der Waals interaction high if molecular weight is higher. So with the iodoform, CHCl3, the molecular weight of CHI3 will be more than CHCl3. That's why we found that CHCl3 chloroform is a gas, or liquid, very volatile liquid. But CHI3 is solid. That's the reason. If you are getting one gas in the lab condition, that is very difficult to analyze. But you are getting a solid crystal of iodoform, and that is very easy to analyze and very easy to observe. Okay, that's the reason. Okay, I hope you have understood it. And the one more thing, in iodoform test, the final product will be just the salt of just the carboxylate salt. So we are starting with carbonyl, but the final product will be always carboxylate salt. Okay, so now we have done the oxygen test, most of the oxygen test. Okay, next is oxygen compounds. Final oxygen compound is of ester. Now ester, this test generally we don't perform because ester molecules given in the sample, unknown sample, is very less. But you have to know the procedure at least. Two tests are there: hydroxamic acid test and then hydrolysis test. We know with hydrolysis, what happens? We get ester hydrolysis gives acid and alcohol. So, and if the we perform the test with phenolphthalein, add NaOH and phenolphthalein. If we add NaOH, then we know phenolphthalein in base medium, this is pink. And when we boil it, the dissociation of ester into acid and salt, this is called saponification reaction. What will happen? The carboxylate salt and alcohol. And carboxylate salt, this will be mostly neutral, and this alcohol will be little acidic. And that's why we know phenolphthalein in acidic medium or neutral medium, it is colorless. That's why it is colorless. So phenolphthalein, with the phenolphthalein color change, we can observe the reaction. Okay, next test is hydroxamic acid test. This is NH2OH. It is basically hydroxamic acid. We know the ester will be converted to sorry, NH2OH is hydroxylamine. NH2OH is hydroxylamine. The product will be hydroxamic acid. How the product will be getting the product? What we have to do? Nitrogen lone pair. This is attacking, and this pi bond shifting, pi bond again back. Then OR will be removed. Okay. Then R-OH will be formed, and this part is called hydroxamic acid. And this hydroxamic acid gives ferrichloride test, and the final product is purple and deep red in color. Okay, there is not so much thing in understanding like that, but you have to practice writing these equations, writing these special factors. Any reaction that involves any special factors or questions I am discussing you, and that's the most crucial part I am discussing here, right? And that is the most crucial part, and the reaction in every book you can get that. Okay, this is the some answer key. We will be giving you some homework question, and these are the answer keys. Okay, next, now nitrogen compounds. This compounds test we will perform only if we get presence of nitrogen in the Lessine experiment. In the Lessine experiment, if we get the nitrogen present, then only you will perform this kind of test. And with that, our first compound is amine group. What will happen? Add what we have to do? Add alkali solution, that is NaOH, in the organic compound solution. So you have to add NaOH. What will happen? OH minus will attack here, this one, then NH2 will remove. So what will happen finally? Finally, what will happen? OH will be connected to there, and NH2 minus will be removed, and NH2 will abstract the proton and will be converted to ammonia. And ammonia, you will get ammonia effervescence. Okay. Now, when ammonia gas will be removed, one very famous test of ammonia, this is ammonia and HCl. You know, in your childhood books of 11 12, you have understood, you have read most probably that this is the kind of reaction where two gas combined to give a solid. NH4Cl solid is formed when a rod dipped in, a glass rod dipped in HCl. If you put it with the test tube with effervescence of ammonia, that gives a solid, black, solid, dense, white, dense NH4Cl vapor, NH4Cl vapor, and that is basically solid, but solid molecule, but they are very fumable, so solid vapor. Okay, so this is a very important reaction. Next one is test of amine. This is your task. If you have read the nitrogen compounds, you have definitely read this test of primary, secondary, and tertiary amine. This is your homework to study by your own. Okay, one very famous test is the beta naphthol test, and that is basically a coupling reaction. These are very common reaction, azodite test and this simple test, and these are the procedures explained there. Okay, I'm not going to discuss this because this is very simple. Once you will read this, you will definitely understand it. Okay, now next, final slide, I hope so. Unsaturation test for the alkenes. In class 10 book, this reaction is given in organic chemistry, because alkene, we know, if we have unsaturation, then if we treat with bromine water, then bromine water is basically red, not mostly red it is. Okay, here it is written that orange red, but it is red. So you have a bromine water solution and this is red, and if you pass alkene through it, what will happen? This red color will be discolored. So our alkene and bromine, how the reaction occurs, actually the mechanism of the reaction is very fascinating. What will happen? Suppose you have this alkene, what will happen? Br bond Br. Br is non-polar molecule, but here instant polarization occurs. Sometimes this Br becomes delta negative, here become delta positive. This is instantaneous dipole generate, and this pi bond will attack. What will happen? Bromine has lone pair itself. Lone pair will attack here. So what happens? Cyclic bromonium ion forms, Br plus. Then we will have another Br minus. Now this Br minus attack from backside, and from SN2 fashion, this gives the, sorry, from SN, not from SN2, from SN1 fashion. There is a different chemistry of ring opening of bromonium ion. That's a different chemistry. So this is basically the mechanism. Through cyclic bromonium ion, finally this product will be formed. This pi bond dissolves and one bromine here. So this is our final product. So 1 mole of bromine is enough here, but for alkyne, similar two-step reaction will occur. First step, second, the pi bond, alkynic pi bond will break, and second, the alkenic pi bond will break. Overall, we will be getting the colorless solution. Next, the BARC test solution. This is also very popular. This is the dilute solution of KMnO4 itself. What happens? KMnO4, with the KMnO4, if we add in water, this simple reaction occurs. And if we put alkene with this, finally our product is like this. And if we oxidize it, finally we will be getting carboxylic acid. So this is the reaction, this is the process. This is very simple. So unsaturation test, it is also not so popular. Okay, not so popular, but yes, in the syllabus it's mentioned, so we have to read it. At least we have to know what things are, what are the tests. Okay, Now we have studied almost all of the tests of functional group. Now it is your homework to read all the question and attempt this, and your answer key is here. Here is your answer key. First try yourself, try reading and make a good note itself. Make a very good note of this segment, and that will be your compact note. You will have a very compact note to revise, isn't it? So one and only source you will have, and that's all. There is no advanced chemistry or something unconventional behind this. So that's all. If you have some more doubts, you can ask in the comment section, and definitely ask that 4 questions of static ammonium nitrate in the comment section. Okay, till now, bye bye, have a nice day. Thank you.